Hello, welcome. This is HL Chemistry Investigation 9.1b, our redox titration. Now, we had planned to titrate iron 2 with manganese 7. That can't happen because we don't have the chemicals, and I don't have a simulator that does that. Instead, what we're going to do is what's called an iodometric titration. We have a simulator that's going to take care of this for you. We'll be titrating vitamin C with some potassium iodate. All right. The due date for this, I believe, is the 24th. It's Tuesday, whatever day that is. I forget at the moment right now, so probably not the 24th. So to get to the simulation, you're going to go to Google, and you're going to type in Chem Collective. Yeah, my audio didn't record correct, so I am doing a voiceover right now. Once you get to Chem Collective, it is the first hit you get. This is a website put up by Carnegie Mellon University in Pittsburgh and the National Science Foundation. It's amazing. It is geared towards university students, so it's a little more advanced than we need. But you're going to go to Analytical Chemistry and Lab Techniques, Redox Titrations, and there's the only one there. Determine the amount of vitamin C in a peach. So I'm going to remove myself so you can see here. You can click Go, or you can just click on the title. Either way will take you to the simulation. Once you get here, okay, this is what it looks like. The top of the lab describes the chemistry that's going to happen. It describes all the solutions you'll be using, gives you a picture of the setup, and then down here is the virtual lab space. Right now it's blank because it didn't load properly. This happens sometimes. All you need to do is refresh, and I believe I refreshed here and it still came up bad, so I'm going to cut to when it finally uploaded for me correctly. You'll notice it. We'll see it in just a second. It may take a few tries. You might have to back out and come back in. So this is the lab space. All right, you'll see there is a stock room on the left with 3 tabs: solutions, glassware, and tools. Okay, and I think I was just reviewing the goal there. Down to the bottom, you can enter your answer, and it auto-checks your answer whether or not it's correct. Every time you reload this lab space, the unknown value resets and recalculates. Okay, so try to avoid refreshing or navigating away and coming back, because it resets and you'll have to start over. All right, so you have several solutions here. You have distilled water, potassium iodate, potassium iodide. You have some ascorbic acid stock solution to use to check your potassium iodate stock solution that you need to make, but we're not going to use it. We have some HCl, some starch, and our peach solution. This is the unknown. This is what gets recalculated every time you refresh or reload. So try to avoid doing that. Instead, what you want to do is use this clear workbench under the edit key. Don't use the add new workbench or refresh at the top. So we're going to rename this workbench real quick. I think I'm having trouble spelling here. It's been a long day. Invest 9.2b. Okay, so let's review the chemistry here. So this reaction happens in a series of 2 different reactions. The first one uses potassium iodate, KiO3, and reacts it with potassium iodide. There's our KiO3. Potassium iodate reacts with potassium iodide in the presence of an acid, H+, to form iodine, and then some potassium ions and some water left over. This iodine reacts with the ascorbic acid that we're interested in. Okay, in a 1-to-1 ratio, it forms this dihydroascorbic acid and some iodide ions and some acid, H+. Okay, so as this reaction proceeds, these are both fast steps in a reaction. These are both pretty fast reactions. They happen concurrently. As we're making the iodine by reacting potassium iodate and potassium iodide, the iodine reacts with the ascorbic acid. As long as there's ascorbic acid around, there is no iodine. Once the ascorbic acid is used up, the iodine persists. It remains in the solution, and then this excess iodine reacts with starch to form an intensely blue-colored complex. You may remember this from biology. It's used a lot. We use it a lot in chemistry. This starch complex is called a starch-iodine complex. It has a very dark blue-black color and is very useful as an endpoint because it has a very sharp endpoint. As soon as we have iodine left over, as soon as we've used up our acid, we get this color change. All right, so we have a brief setup here. We have our stock solute, or our food sample, the peach juice, which is going to have potassium iodide, HCl, and starch in it, and then we have our potassium iodate solution at the top in the burette. We're going to use the solid potassium iodate to make a stock solution. I'm going to do the calculations for you, and I'll run you through that in another video. We have potassium iodide solution. This is used to make the iodine. We're going to use 5 mils of this for each titration. HCl, 2 molar. It's necessary to give us those acidic conditions. We're using 4 mils of HCl solution in each titration. And the starch is our indicator. This is going to react with any leftover iodine to give us that dark blue color, indicating that the reaction has completed. Okay, we'll use 3 mils of the starch solution. The potassium iodide, the HCl, and the starch are all far in excess, so their amounts will not affect our titration. This ascorbic acid solution we're not going to use. It is a very precise concentration, and it's used to kind of test out your potassium iodate stock solution. We're not going to do that. I'm going to use this value to calculate a roundabout concentration for our iodate solution. Other than that, we're not going to use it. The peach solution is our unknown. Every 10 mils of this solution equals the amount of juice you would get from 1 medium peach, which is roughly 100 grams of peach. Okay? So we will have to use these materials to create a stock solution of potassium iodate, mix all of the chemicals in our unknown, and then titrate with our iodate solution so that we can find the number of milligrams of ascorbic acid in 1 medium peach. Okay, you can enter your answer in here to 4 sig figs. It is pretty good. It is possible to get there. I have tried it 2 or 3 times today, and it does work. It gives you a little bit of wiggle room, but again, every time you reload, you get a different value. Okay, so in the next video, I will take you through the process once so that you have something to work with. I'll show you how to mix up your solutions, and I'll run through the calculation with you, and then you will perform this on your own. Take it easy. We'll see you in the next one.